So let's take a look at a second day of working with our limits with trig functions. We still have our two rules, and that is that the limit as x approaches 0 of sine of x over x is 1, and the limit as x approaches 0 of 1 minus the cosine of x over x is 0. So if I take a look at number 1, we want to find the limit as x approaches 0 of the sine cubed of x over x squared. If I have powers, then I want to go ahead and break this up. So I'm going to go ahead and rewrite this as the limit as x approaches 0 of, I have a sine on top times another sine times another sine. We've got 3 sines being multiplied in the numerator, and we have 2 x's being multiplied in the denominator. I know that if I'm finding the limit as x approaches 0 of sine of x over x, I can replace that with 1. So I'm going to have a 1, another 1, and so I'm really just finding the limit of the sine of x when x is approaching 0. So if I plug a 0 in for my x, now that I no longer have a denominator of 0, the sine of 0, my y-coordinate at 0, is 0. We can do the same thing for question number 2. This time, we've got the sine of 2x raised to the 5th, so we have 5 of those multiplied together, over a 4 times x to the 5th. So let's go ahead and break it up just like we did in number 1. I'm going to rewrite this as the limit as x approaches 0 of, I've got 5 of these sine of 2x's being multiplied together. So there's 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. In the denominator, I've got the 5 x's, so I'm going to go ahead and put those all in. But I also have a 4, so I'm going to break up that 4 as a 2 and a 2. So now, if I take a look at my first two fractions, I have the sine of 2x over 2x, that's going to reduce down to 1, times, in the second fraction, that's also going to reduce down to 1. In the third fraction, in order for my sine of 2x over 2x to cancel, I have to multiply top and bottom by a 2 over 2. So when I do that, now my sine of 2x over 2x cancels to 1, and I'm left with a 2. I can do the same thing for the fourth fraction. I can multiply top and bottom by 2 over 2, and so that's going to leave me with a 2 times 1 is 2. And then I can do the same thing for the fifth fraction. I can multiply top and bottom by 2 over 2. So my sine of 2x over 2x is 1 times 2 is 2. And so I'm left with 2 times 2 times 2 is 8. Now for question number 3, when I plug a 0 in, I don't have a denominator of 0. If I don't have a denominator of 0, then I can go ahead and just evaluate it. So looking at question 3 now, I can plug my 0 in for my x's, and I'm going to have the limit as x approaches 0 of 1 minus the cosine of 0 all over 1 plus the sine of 0. At 0, my cosine is 1, so in the numerator I'm going to have 1 minus 1 over. In the denominator, my sine at 0 is 0. And if I'm left with 0 over 1, that's going to reduce down to 0. So if I don't have a denominator of 0, then I can go ahead and just plug the value in and evaluate. For question number 4, notice your numerator looks very similar to what we dealt with back in our trig functions. We know that sine squared plus cosine squared is equal to 1, one of our Pythagorean triples. So if that's the case, then I could go ahead and subtract that cosine squared from both sides, and I'm going to have that sine squared is equal to 1 minus cosine squared. So some of my trig way back in my old chapters is coming back to help me out, which means I can go ahead and replace my numerator with sine squared. So I'm going to rewrite this as the limit as x approaches 0 of sine squared of x over 2 times x squared. So if I think of this as a 1 out in front, let's rewrite our fraction as 1/2 times a sine of x over x times another sine of x over x. We know that the limit as x approaches 0 of the sine of x over x reduces down to 1. So this is going to reduce to 1, and this is going to be reducing to 1. And I'm going to be left with 1/2 times 1 times 1 is 1/2. Now let's look at the fun problem. Number 5. For number 5, it looks tricky and mean, but if we go back and use some of our trig rules, it's going to help us out. For question number 5, it says I want to find the limit as x approaches pi over 2 of pi over 2 minus x all over the cosine of x. Now, unfortunately, I can't just plug that pi over 2 in for my x because that will give me a denominator of 0. So I have to figure out how to get rid of the denominator of 0. Our hint says let theta be equal to pi over 2 minus x. That's my numerator. So if my theta is equal to pi over 2 minus x, and I'm told that my x is approaching pi over 2, as x gets closer and closer to pi over 2, if theta is pi over 2 minus x, then I can go ahead and say that theta is approaching 0. So if I go ahead and rewrite this limit in terms of theta, I want to find the limit as theta approaches 0 of what? Well, if theta is equal to pi over 2 minus x, and I solve my hint here for x and get x alone, then I can rewrite this as x is equal to pi over 2 minus theta. So now I can replace the x's with pi over 2 minus theta. So in the numerator, I'm going to have pi over 2 minus pi over 2 minus theta all over the cosine of pi over 2 minus theta. So if I simplify my numerator, my pi over 2's are going to cancel, and I'm just left with theta over. In the denominator, I have the cosine of the difference of two angles. So using my sum and difference formula, I can extend this out as the cosine of the first, pi over 2, times the cosine of the second, theta. Cosine always has opposite sign, plus the sine of pi over 2 times the sine of theta. Well, now I can go ahead and plug in my values of pi over 2. At pi over 2, my cosine is 0 and my sine is 1. So in the denominator, 0 times cosine is going to cancel, and 1 times sine is sine. So now I'm left with the limit as theta approaches 0 of theta over the sine of theta. Oops, having a hard time writing the sign there. Sine of theta. So then, if I go ahead and multiply top and bottom by a 1 over theta, and 1 over theta, in the numerator I get 1 over the sine of theta over theta, and my denominator is going to approach 1. So I'm going to be left with 1 over 1, which is equal to 1.